All right, we're on lesson 10, which is solving systems of equations in three variables. In Algebra 1 on page 42, we said to be able to do the order of operations, you can only have one variable or one name. If you have more than one, you must name one in terms of the other and use substitution, or use special rules like consecutive, consecutive even, consecutive odd. Then on page 52, we learned about things in a ratio. To name them in terms of the same variable. And then below that it said, if you have one variable, how many equations do you need? One. If you have two variables, how many equations do you need? Two. If you have three variables, how many equations? Three, etc. Okay? Now, how do we solve? What's the only way we can do the order of operations? If you only have one variable or one name. You cannot use the order of operations until you get down to one variable or one name. So if we have a 3 by 3, we've got to take it from 3 with 3 down to 2 with 2 down to 1 with 1, then you can solve. The only other thing that might happen in algebraic settings is you may end up with a quadratic somewhere where you've got an x and an x squared, and then you use your quadratic rules, okay? Now, when we solved in two variables with substitution and linear combination, we went from 2 with 2 down to 1 with 1. Now we're starting with 3 with 3. So we're going to go 3 with 3 to 2 with 2 with 1 to 1 with 1. If they're complex, there may be some easier ways of getting there. So we're going to start out with some easier ones and then work our way into the more complex, where we have to go from a 3 by 3 to a 2 by 2 to a 1 by 1. Okay? Now, number one, we already have an isolated variable, so this one's a little bit easier. It says y is equal to 3x. Now, if you notice, though, we've got three variables, but the first two statements have the same variable, right? So in yellow, we have a 2 by 2 situation, and then we have a 3 situation. So we're not having to solve as if we have three equations in the same three variables. Buried in this situation is 2 with 2. And so we're going to solve the 2 by 2 to get it down to a 1 by 1. And then we're going to start plugging in. Now, to do that, we're going to use substitution. It says y is equal to 3x. We're going to put that in place of y. So we have 2x plus 5 times my y, which is 3x, is equal to negative 34. Let's see, we got that. What that did is take me from an equation in two variables to an equation in one variable x. Once I'm down to one variable, then it's order of operations time. Now, I'm going to do the multiplication here first and get 2x plus 15x equal negative 34. Now I'm going to combine like terms and get 17x equal negative 34. I can do nothing else to simplify, so I'm going to undo multiplication by division. Watch our signs. We get x equal negative 2. Now, my answer is an XYZ situation. It's going to be x, comma, y, comma, z. Okay, a three-variable ordered pair. Ordered triple. Can't say ordered pair, can you? A three-variable ordered whatever. All right. Now, I can plug back in to this one and find my y, right? So y is equal to 3 times negative 2, so y is equal to negative 6. So now I've got the second member of my ordered set. Now what can I do? Plug them both into the third one. So I'm going to put the x there and the y there, which will leave me with only a z in the third equation. So I'm going to take 3 times my x of negative 2 plus 4 times my y of negative 6 plus 5z is equal to 5. And then I solve for z. Now, I've got two multiplications I can do. I'm going to go ahead and do them both. 3 times negative 2 is negative 6. 4 times negative 6 is negative or minus 24. Plus 5z equal 5. So we did a couple of multiplications there. We're now going to combine like terms. Negative 6, negative 24 is negative 30. Plus 5z equal 5. I've done all I can do to simplify, so I'm going to start undoing. I'm going to get rid of 30 negatives with 30 positives. We get 5z is equal to 35. Now I'm going to undo multiplication by division, and I get z equals 7. So there's the third member of my ordered set. Now you should be able to plug back into all three of those, the appropriate variables, the numbers, and realize it makes all three true, right? For this to be a solution, it has to make all three equations true when you plug back in your x's, y's, and z's, whatever the case may be. Any questions on number 1? So we kind of are tiptoeing into this. That one had a 2 by 2 already, so we just took it down to a 1 with 1 and went from there. All right. When we go to number 2, number 2 has two 2 by 2s again. It's got a 2 by 2, excuse me. It's got two 2s. But then it's got one with 3. So we don't have to go from 3 with 3 down to 2 with 2 because we've already got 2 with 2, you see. But we're going to have to take one from standard form to slope-intercept form to be able to substitute in, right? So if we do this one, we're going to take, excuse me, we're gonna move our x to the other side, remembering to change the sign when you cross over. So we would get negative 5y is equal to negative 3x plus 30. We move the x to the other side. Now we're going to get the junk off of y. So we're going to undo multiplication by division. Remember that we're going to be distributing that division through that parenthesis. I remember that. So we're going to have negative 3 divide negative 5 is positive 3/5. When you divide with the same sign, it's positive. 30 divide negative 5 is negative 6. Is everybody good with that? We went from standard to slope-intercept. We needed an isolated variable. We could have solved by linear combination method, right? The elimination method, which we'll do later. I just went ahead and solved this one by the substitution method. And so what we can do is we now can take this and we can substitute it in place of y, and we can solve for x. Now, let me ask you, is it generally easier on us to change it to slope-intercept and plug in? What usually happens in a situation where you change it to slope-intercept? You get this messy fraction thing. So we can solve by substitution, but we get something that's really harder to deal with, right? And so what we're going to realize is if you already have an isolated variable, you just as well go ahead and substitute. But if you don't have an isolated variable, then when you isolate that y, you're going to get all that fraction stuff. It's not the prettiest way to solve. And so we're just going to back out of that and say, I'm not going to do that. There's plenty of space on your paper to trash that idea and start over, or just use your eraser. So what we're going to do is say, okay, we're going to solve these by the elimination method. I'm going to have 3x minus 5y equal 30 and 4x plus 3y equal 11. And I'm going to solve it by the elimination process, okay? Since substitution is going to create some crazy fraction stuff. All right. I probably should have said don't write this down. I'm going to show you what not to do. But that's okay. Now, do you want to eliminate the x's or y's first? It's not going to matter. Which ones? Y's. If we're going to eliminate the y's, we need the smallest thing 3 and 5 will both go into, like the least common multiple, which would be 15. And remember, we want one to be positive or one negative. Does it matter which one's positive and which one's negative? No. Which one do you want to be positive? Top. Somebody said the top. So we're going to make the top positive and the bottom negative. Everybody with me so far? Right. Would have been easier the other way, but that's what somebody said, so we'll keep trucking with it. You're right. Oh, it's out. We'll keep trucking. Yeah. Might have been easier to leave the top negative since the 5's already negative. Correct. It's not going to matter. That's what I would have done. But somebody said the other, and I said, oh, that's fine. We'll go with it. But it's okay. Okay, so now we're going to think negative 5 times what number will give me that positive 15? Negative 3. If you're not sure, then divide. 15 divided negative 5 is. Okay? And then on the bottom, we're thinking 3 times what number will give me that negative 15? Negative 5. And again, we could have avoided some sign stuff if we had thought a little bit there. So that's a negative 5, but it doesn't matter because signs shouldn't scare us anyway. So now we're going to distribute. Negative 3 times 3x is negative 9x. And negative 3 times negative 5 is positive 15y. And negative 3 times 30 is negative 90. And we distribute on the bottom, and we're going to get negative 5 times 4 is negative 20x. Negative 5 times 3 is negative 15y. And negative 5 times 11 is negative 55. So we have created additive inverse y's. So now we can combine, and the y's are eliminated. So we get negative 29x, when you add or subtract with the same sign you add and take the common sign, is equal to negative 145. Notice what we did. What did we just do? We went from 2 equations with 2 variables down to 1 equation with 1 variable. And once we're down to 1 equation with 1 variable, we can solve using the order of operations. So we're going to undo multiplication by division, and we would get x is equal to 5. So that's the first part of an ordered set of 3, because it's the x. It's going to be x, y, z. Now, how we're going to get our y? We got to plug the x into one of these originals, right? So if we just take this original, 3x minus 5y equal 30. We need a place that's got an x and y in it, right? And we're going to plug in that x into a place that has an x and y to solve for our y. So we're going to have 3 times an x of 5 minus 5y equal 30. We can do multiplication, so we get 15 minus 5y equal 30. Undo addition by subtraction, so we subtract 15. And we're going to have negative 5y equal 15. Everybody see what we're doing? Divide by negative 5. We get y equal negative 3. And so the second element in our ordered set is a negative 3 for y. So we plugged in the x where there was an x and a y, and we solved for y. Any questions so far? Pretty good. Now we've got an x and a y. So we want to plug the x and a y where there's an x, y, and z, right? So we're going to have from this equation 5 times the x of 5 plus 7 times the y of negative 3 plus 9 times z is equal to 58, and we can solve for the one variable z. And I'll move some stuff out of the way. So we're going to do this multiplication in this one. We'll have 25 minus 21 plus 9z equal 58. Combine like terms, 4 plus 9z equal 58. We've done all we can do to simplify, so now we undo addition by subtraction. We get 9z is equal to 54. Undo multiplication by division, z equals 6. So there's the third member of our ordered set of 3. So the answer is 5, negative 3, 6. We could plug that back into all 3 and see that it makes them all true. So we started out with the same 2 and a third one. We went ahead and took the 2 with 2 down to a 1 with 1 and solved, and then started plugging back in. So that's a little more complicated because we had to, we solved that one with elimination. Started out substitution and said, yeah, that's fractiony, messy looking. We'll do the other way, which is why we learned the other way. Any questions so far? Is anybody there? It's a lot of, take some space to do these. All right, number 3. Now, number 3 is a little more complex because it didn't have a 2 with 2. We start out with 3 equations in the same 3 variables. All right, here's what we got to do. We've got to go from 3 equations with the same 3 variables down to 2 equations with the same 2 variables, down to 1 equation with 1 variable, and then you solve and then start substituting back in. Now notice how I highlighted that. I'm going to use the top 2 to get down to a 2 to 1 with 2. And I'm going to use the bottom 2 to get down to 1 with 2. You understand that? I want to eliminate the same variable out of the top 2 as I eliminate from the bottom 2. It doesn't matter which one you eliminate first. So tell me which variable you want me to eliminate first. Z, thank you. So out of the top 2, we're gonna separate these 2 things, okay? I'm just going to bring it here so you can't miss it. We're going to have 3x plus 7y plus 4z equal 57. Okay, yeah. I'm trying to remember. Pause. So we're going to take the top 2 and eliminate a variable. And then we're going to take the bottom 2 and eliminate that same variable so that we get down to 2 with 2, okay? And we decided to get rid of the z's. The least common multiple between 4 and 9 is 36. So we want a positive 36 and a negative 36. So we're going to multiply through by whatever it takes to get the 36 and negative 36. Okay? So we're going to think 4 times what will give me my 36? 9. So I'm going to multiply by 9. 9 times what will give me my negative 36? Negative 4. So I multiply by negative 4. This would be a really good time for my smartboard to be perfectly accurate. It's off just a hair. So bear with me. We've got 9. We're going to distribute, right? 9 times 3x is 27x. 9 times 7y is 63y. 9 times 4z is 36z. 9 times 57 is 450 and 63, which is 513. Is that right? Somebody try that. What is it? 513. We're going to distribute here. Negative 4 times 8x is negative 32x. Negative 4 times 5y is negative 20y. Negative 4 times 9z is negative 36z. Negative 4 times 77, 280, 280, 304, right? 8, 308, negative 308. Thank you. So we've eliminated the z's. 27 minus 32 is negative 5. On the x's. On the y's, we got 63 minus 20 is 43. And 513 minus 208 is 308 is 205. So we went from 2 equations in 3 variables down to 1 equation in 2 variables. But we got to get a second equation in 2 variables. So we do the same thing we just did with the bottom 2. We use the top 2, now we're using the bottom 2. So we use the middle one twice. Okay? So now we're going to do the same thing with the bottom 2. 8x plus 5y plus 9z equals 77. 11x plus 2y plus 6z equals 56. We need to eliminate the same variable. So we're going to eliminate the z's. And 6 times 9 is 54, so we want a positive and negative 54. Actually, that's not the least common multiple. We could use an 18 and a negative 18, right? I should do that. I shouldn't say 6 times because it's small multiple, and that'll keep our numbers smaller. So the least common multiple between 6 and 9 is 18. So we're going to create an 18 and a negative 18. So we're going to multiply through by whatever it takes to make that happen. So I think 9 times what is 18, 2. 6 times what is negative 18, negative 3. Let's see if we got that. And then we distribute. I'll do this in blue. 2 times, that was an 8x, is 16x. 2 times 5y is 10y. 2 times 9z is 18z. 2 times 77 is 154. Negative 3 times 11 is negative 33x. Negative 3 times 2 is negative 6y. Negative 3 times 6 is negative 18z. Negative 3 times 56 is negative 168. It would do good to double check all your answers. One little mistake at the top of this and it's not fun to start over. Good. So y'all checking me as we go. All right. We eliminated the z's again. So this time we have 16 minus 33 is negative 17. 10 minus 6 is 4 for the y's. 154 minus 168 is negative 14. So what we have created here is two equations with the same two variables. So we've gone from a situation where we have three equations with the same three down to a situation where we have two equations with the same two. Now we've got to take the 2 with 2 down to a 1 with 1. I understand that. So we're going to take these two new ones, negative 5x plus 43y. I'm just looking for a place to put it, 205. And then negative 17x plus 4y is equal to negative 14. If I had done this as a smart notebook, I could just extend my page and keep going down. That's what Miss Ballard does. That's a good thing. Now, I need to eliminate another variable. So this time we'll eliminate whichever one. Which one looks easier? Neither one's very pretty. Let's just eliminate the y's. The least common multiple would be the product of them, which is 172. So we need to produce a positive and negative 172. So we're going to multiply through by whatever it takes to make that happen. So we think 43 times what is 172, and it's that 4. 4 times what is 172, and that needs to be a negative. So it would be a negative 43. So we got that. And so we distribute. 4 times negative 5 is negative 20x. 4 times 43 is 172y. Is equal to 4 times 205 is 810. 20. Thank you. I'm glad you're double checking. 43 times 17 is 731, and it's positive. 43 times 4, negative 172. It was a negative 43 and a positive 4, negative 172. And then positive 43 and negative 14, 602. We've created additive inverse y's, so those cancel. When we combine our x's, we'll get 711x is equal to negative 218. Was that positive 820? That's negative 820. It's a positive 820. Oh, that's good. Here, it's here. It just was hiding right there. So we're going to get, yeah. So when we add, we get 1422, right? Yeah. So it's going to come out. That's it. I just couldn't see my signs. I thought that little wing on that 8 was a negative, and it's not. So we're going to divide by 711. That's cool, I guess. And we get x is equal to 2. So we finally got a variable, 2. Yeah. So now we just need to find a place to plug that in where there's only one other variable besides it, right? And this looks like a good place just because there's room below it. So there's an equation with x and y. So I can put in the x and solve for y. So I'm going to have negative 17 times my x of 2 plus 4y equal negative 14. So we're going to have negative 34 plus 4y equal negative 14. I'm going to white out my bottom of all my start menu. There we go. Buy myself a little space. That didn't like it, did it? Didn't want me to do that. So we're going to add 34 to both sides. If we did, we would have 4y is equal to, if you add 34, there it goes. Changed its mind. So we would have 4y is equal to 20. Undo multiplication by division, and we would get y equal 5. So there's the second member of my ordered set. So now we've got x and y. So we can pick any of the 3 with 3, right? Of the 3 with 3. I'll just use the top one. So we're going to go back to this top one with 3 variables. 3x plus 7y plus 4z equal 57. And we're going to plug in our x and y to get our z. So 3 times our x of 2 plus 7 times our y of 5 plus 4 times z is equal to 57. And we can solve for z. So we're going to do the multiplications. 6 plus 35 plus 4z equal 57. We'll clean out some more space here. Whoops, there you go. So we're going to combine like terms. 41 plus 4z equal 57. We've done all we can do to simplify, so now we undo, subtract 41. We get 4z is equal to 16. We're going to undo multiplication by division, and we're going to get z is equal to 4, and so we have the last member of our ordered set. So we went from 3 with 3 down to 2 with 2 down to 1 with 1 and started substituting back in. Understand that? Again, how did we do go from 3 with 3 to 2 with 2? We took the top 2 and we used those to solve to eliminate a z, and then we took the bottom 2 and we used those together to eliminate z. That took us to the situation over here where we had 2 with 2. So we used those to eliminate another variable y, which finally got us down to a 1 with 1, at which point we could use the order of operations and then start plugging back in. Okay? Any questions on that? We'll stop there. I think there's one more example, and was there one more example? Yeah. And we'll do it in another video. Appreciate your attention.